Good morning. My presentation today is on photoelectric transducer. Over the next half of an hour, I will explain what these devices are, how they work, their types, important characteristics, and their wide range of applications. By the end of this session, we'll get a clear idea, understanding of why photoelectric transducer are so important in modern technology. So, It, as an introduction, a transducer is a simple device that converts one form of energy into another. For example, a microphone converts sound into electrical signals, while a speaker converts electrical signals back into sound. Now, a photoelectric transducer specifically converts light energy into electrical energy or signals. So, why is this important? Well, think about how many devices around us respond to light, automatic doors at shopping malls, uh, smoke alarms, even the brightness adjustment in your mobile phone. These all rely on photoelectric transducers. So, in simple words, they sense light and they give us an electrical signal that can be used for measurement or control. So, So, what are the principle of this operation? Okay, so the working principle is based on photoelectric effect, a concept explained by Albert Einstein in 1905. So, when light of sufficient energy falls on a photosensitive surface, it knocks electrons or expels electrons out of the material. These electrons create a current which can measure. Okay, so to make this reliable, uh, uh, reliable, imagine sunlight falling on a solar panel at your home. So the light doesn't just heat it, it actually releases electrons inside the panel. Okay, so this generate electricity. Okay, that's a photoelectric effect at work. So this principle is a foundation for all photoelectric transducers. So what are the types of photoelectric transducers? Okay, first one is photo uh, photoemissive cells. Okay, so these directly release electron when light falls on them. They were some of the earlier types of that were used. Okay, so next one is photoconductive cells. So here light reduces the resistance of the material. The more light, the more current passes. Okay, and the third type is photovoltaic cell. Okay, we have familiar with this. These are the most common directly generated voltage from light, just like solar cells. Okay, so next one is photodiodes and phototransistors. Okay, these are the modern semiconductor devices, very sensitive, very fast, and widely used in automation and communication systems. Okay, so each of these has strengths. For example, photodiode are very quick. Okay, while photovoltaic cells are good for generating continuous power. Okay, so next is the characteristics properties of uh, this photo conductive materials. Note. So these photoelectric transducers are valued because of their important characteristics. Okay, so the first one is they are high sensitive to light. Okay, so they can detect even weak light. Okay, now second one is spectral response. Okay, so like different devices respond to different wavelengths, like infrared or visible light. Okay, so it has spectral response and it is fast response time. It has okay, like they react quickly, which makes them useful in automation also. Okay, and reliability and durability. Many are solid state devices, so they last long. Okay, so and require little maintenance also. Okay, so a simple way to understand is just like our eyes are sensitive to light, photoelectric transducers are the electronic eyes of machine. Okay, so coming to the applications, so automatic doors in malls and hospitals, they sense when someone comes close. Okay, so we have heard of like RFID or the tag we used. Okay, like it's also same principle or working principle they obey. So the industrial automation, okay, they are for counting objects on a conveyor belt. Now medical instruments like pulse oximeter, which measure oxygen in our blood, using light. Okay, safety devices such as smoke detectors. Smoke detectors are widely used in buildings now, in colleges, industries, etc. And renewable energy, especially solar panels, which are photovoltaic transducers. Okay, so if we look around, we can realize a interact. We interact with the photoelectric devices almost every day without noticing. So coming to the next advantages and limitations. Okay, so the first advantage, it's very sensitive and accurate. Okay, uh, it has no physical contact is needed, no physical contact is needed to work on, and quick response time. Okay, fast response, easy to integrate in the system. It is very easy to integrate in systems, and its limitations are uh, it affected by dust and dirt, fog, can be blocked light and reduce performance. Okay, so they can sometimes be affected by ambient light interference also, sunlight or artificial light, etc., etc. So this is why in industries they often use protective housings or filters to make sure the sensors work correctly. Okay, so this is all about photoelectric transducers. So as a conclusion, photoelectric transducers are devices that senses light and convert it into an electrical signals. They are based on photoelectric effect. They come in different types like photo emissive cells, photoconductive cells, photovoltaic cells, and photodiodes we have discussed. So these characteristics makes them reliable, fast, and sensitive. So most importantly, the applications range from our daily life, like doors and alarms, to critical areas like medicine industries and renewable energy. So without them, automation, safety, and energy systems would be incomplete. So, so this is all about the presentation. Thank you and have a nice day.